morning and welcome to our next Challenger Connection. I'm Commander Jennifer, and today we are going to be building on some lessons that we've been doing about density. So if you remember what density is an object's mass divided by its volume. Mass means how much stuff is in an object. Volume means how much space an object takes up. So Commander Melissa and I did our boats. Remember the foil boats we did and looked at different densities? She made a density column, that rainbow column with you. So today we are going to make some fireworks in a jar. Yeah, so what you're going to need for this activity is you're going to need a clear cup or jar. I'm just using a mason jar with water. So you want to fill it up about 2/3 of the way with water. Then you need vegetable oil, some kind of oil, vegetable oil here, and food coloring. So if you remember in Commander Melissa's lesson, she talked about different densities of liquids. So water, pure water, has a density of 1. Now this is tap water. It's not quite pure water, but it's pretty close. So pure water has a density of 1. Anything that has a density of less than 1, which is the water's density, if you put it in the water, it's going to float. Anything that has a density that's greater than the water's density, which is 1, when you put it in the water, it will sink, right? So what we're going to do is we're going to first add some food coloring to our oil and see what happens when we put food coloring, which is the liquid, our food coloring here, into our oil. What do you think it will do? And then we're going to put our food coloring and oil in our water to see what happens and to see if we can make those fireworks. So let's see what happens. All right, so what we're going to do first is we're going to pour our vegetable oil onto our water. What do you think is going to happen when we take the vegetable oil and pour it onto the water? Let's see. And remember, pure water has a density of 1. So where's the oil going? Right back up there to the top. So that tells us the vegetable oil's density is less than the water's density. So it's floating on the top. All right, so now let's add some of our food coloring drops. Where do you think the food coloring drops are going to go when we put them in? Let's see. So I'm going to try to spread them out here. What are they doing? So at first, when I put them into the vegetable oil, they're staying in their drop, but they're sinking to the bottom of the oil. So that's telling us that the food coloring has a density that's greater than the oil's density. And guess what food coloring is mostly made out of? It's mostly made out of water. So since water and vegetable oil have densities that are so far apart, they don't really like to mix with one another. And so what happens is that food coloring, let me zoom in a little closer for you, is just staying there on the top. But now do you see what's happening? The food coloring is starting to drop down into the water and it's starting to disperse, starting to go from areas of higher concentration where it's all in that drop into areas of lower concentration. So we're starting to get some of our fireworks in a jar. Do you see that? And the color is starting to go where? To the bottom. So remember, water has a density of 1. Food coloring is mostly water, but is it all water? Obviously not, because it's starting to sink to the bottom. Look at that. All right, so hopefully you try to make your own fireworks in a jar and show us what happens. What are your results? Do you think you would get the same results if you put your food coloring in your oil first and then poured it in? That would be another part of this experiment to try out. And don't forget, tomorrow is the last day to submit your questions for astronaut Colonel Terry Wilcutt. So don't forget to do that, and you just might be able to ask your question live to Colonel Wilcutt. I'm Commander Jennifer, over and out.